Our speaker today happens to be Justin Bartel. He is the Science Museum of Virginia's Immersive Experience Manager. It's a great title. He holds his bachelor's degree in science and astronomy from the University of Arizona, and he's been working in informal education and planetarium since 2005. We've been lucky enough to have him at the museum since 2013. And he supervises our astronomy program and our dome and the Digistar full projection system. We're pleased that he is here to talk with us today about see outer space without leaving your place. A few housekeeping items before I let Justin take over. Please ask questions, but you can do it right in our chat during the talk. I've got everybody muted. But go ahead and type your questions in the chat, and at the end I will coordinate with Justin and try to answer as many as we can. Remember that your fellow members can see the chat, so please be polite as you're commenting, because we can all see it. And with that, I'm going to turn it over to Justin.
All right, thanks so much, and hello everybody. Thanks for tuning in today. As Tim Schul said, I'm the Immersive Experience Manager at the museum, and really just means that I ensure that the staff and the equipment in the dome have everything they need to put on great shows for you when you're able to visit in person. Now, today's presentation is going to be a little bit like the planetarium shows in the dome, but there are going to be some obvious and not so obvious differences. So I'll put a couple of disclaimers up front as well. We are going to be using the same software that we use in the dome for the presentation today. It's called Digistar 6. It's produced by a company called Evans and Sutherland. And of course, the content that we produce on Digistar is usually projected on a large round screen. And like me, you're probably watching it on a much smaller flat monitor today. So some things on the screen may look a little bit strange. For example, if I put the title back up on the screen for you, you'll probably notice that the text is just a little bit curved. There'll be some other strange things like that. But I've tried to do my best to minimize that for you. So hopefully you can see everything clearly enough on the small screen. If you do miss anything though, feel free to note that in the chat as well. And I can try and circle back to things you may have missed at the end of the presentation. Also, I'm going to spend a lot of time watching the same visuals you are. And for me, that is another monitor off to the side. So instead of looking at the camera like most presenters probably would, I'm going to spend a lot of time looking off to the side. You know, the visuals are the real star here. So I recommend maximizing it on your screen and enjoying that. So with that out of the way, let's dive right in. I thought I would take this opportunity today to show you a few things that have been going on in space. You know, other stories have certainly been dominating the news cycle recently, so you may have missed some events that are taking place in space, and we'll look into the future as well before the end of the show. It's pretty tough to think of a better place to start than with our own planet. And of course, just last week, we celebrated the 50th Earth Day. Earth Day is really about our planet and how we take care of it, but it was inspired by pictures taken by the Apollo astronauts on their missions to the moon. It was the historic Earthrise picture captured during Apollo 8 in December of 1968 that really inspired the Earth Day movement. But what you're seeing right now is not a simulation of Apollo 8. This is a little closer to what astronauts on a later mission would have seen, another one that celebrated a big anniversary this month. The Apollo 13 mission launched towards the moon in April of 1970. And of course, they had that little problem. They made a whole movie about it. And you've probably seen that. But in the movie, they condense everything down to a couple of hours. In truth, after the explosion that crippled the spacecraft, they had more than 3 days left in space before they returned safely to the Earth. And also, as you may imagine, the astronauts didn't spend as much time on sightseeing, taking photographs, shooting video as some of the other missions did. So we don't have a whole lot of views of what happened during the mission for the astronauts. But that started to change as part of the 50th anniversary celebration. An amateur image processor from England named Andy Saunders has kind of gone back, revisited some of the images from Apollo 13, and has tried to improve our vision of that mission. You should be seeing now a couple of images. On the left is the type of view we've seen for most of the last 50 years, kind of grainy. It's 50-year-old imagery, doesn't really hold up. But Mr. Saunders has gone back and reprocessed a lot of that, and he's given us new, unique views of what the Apollo 13 was really like on the inside. A couple of images that I'll add for you. There are many others available online, but on the right side of your screen, this might be a little bit small, but you actually see the control panel for the lunar module that they used as a lifeboat during the mission. And if you look really carefully, there are some little labels they had to add that actually reminded them that the way the controls worked as they were using the lunar module to fly the entire spacecraft stack was totally different from the way they had trained back on Earth. So it looks like duct tape to me that they just wrote on with a Sharpie to remind themselves of the new flying techniques they'd have to use. And then on the left, you see a view of the real astronauts building the famous adapter that they needed to connect the air filters from the command module to the lunar module. The two spacecraft they used during the Apollo missions were built by different contractors, and although they had to fulfill some of the same functions, the different contractors chose to solve some of those problems in different ways. So they needed to scrub carbon dioxide out of the air the astronauts would breathe. So they had filters to do that, but the ones in the command module were square. The ones in the lunar module were round. So when they needed to use some of the square filters in those round holes in the lunar module, they had to find a way to bring them together. So a little bit of real life engineering right there 50 years ago. These new images also give us new views of the service module, the part of the spacecraft that actually had the problem. On the left of the current view is the type of picture we've been seeing for the last 50 years. Doesn't really show a whole lot of detail of what happened on the service module, but Andy Saunders and then NASA have gone back and revisited that imagery. In the center is a slightly sharpened view, and on the right is a brand new view that NASA has used to try and get new insight into what happened on that old mission. Now, speaking of new insights from old missions, also want to revisit the Kepler Space Telescope. That was a spacecraft that was launched over a decade ago to search for planets outside of our solar system. And it did that job by staring at large patches of the sky. And for its prime mission, about 4.5 years, it stared at one particular patch of the sky, and over 9,000 possible planetary signals were detected. These were all flagged automatically by software, and recently astronomers have been going back, looking through that data again to make sure they didn't leave any planets behind. Now, some of them they didn't double check because most of those have already been confirmed as real planets around other stars, but that still leaves thousands of possibilities. So a team of scientists, which actually called themselves the Kepler Planetary Rescue Committee, which it's a great name. They've been going back through these data points, and just recently they published a new discovery from this old data. It is a new planet around a little red dwarf star that is just affectionately called Kepler 1649. Now, Kepler 1649 is about 300 light years away from the Earth. So we're not going to send any real spacecraft there anytime soon. So telescopes like Kepler are our best bet to figure out what's going on out there. Now, Kepler 1649 was already known to have one planet in orbit around it. That one is just called Kepler 1649b. So when we get out there, you're going to see the star itself. Its red color means it's cooler than our sun. I'm going to add the orbit of the first planet. It was announced a couple of years ago. And then I'm going to add the orbit of the new discovery, Kepler 1649c. And both of these planets are about the same size as the Earth, so that's pretty exciting. What's more exciting about this new discovery is that Kepler 1649c orbits in what we call the star's habitable zone. That's the region around the star where temperatures can be right for liquid water to exist on a planet's surface. Now, it's no guarantee. These planets are the same size, about the same size as Earth. And here in our own solar system, we've got two planets about the same size. We've got Earth and Venus. Now, Venus is certainly a little bit closer to the sun. That warms it up a little bit. But it's really Venus's thick atmosphere that has drastically changed conditions on that planet. Its atmosphere is really full of heat-trapping gases, mostly carbon dioxide, and that drives its temperature up over 800 degrees Fahrenheit. So even though this new planet could be, like Earth, if it has a more Venus-like atmosphere, it may not be a very habitable planet. So a little more study is needed to really nail down some of these details. And Kepler, the telescope that discovered this planet, isn't really designed to analyze things like planetary atmospheres. Could probably use another telescope to help out. And speaking of other space telescopes, another real famous one just celebrated an anniversary of its own. So let's head back to Earth and visit the Hubble Space Telescope. It was launched into orbit around our planet in April of 1990. So back on the 24th, it celebrated its 30th birthday. And 30 years in orbit around the Earth, it's had a chance to conduct a lot of really interesting science. I'm going to add to your screens a lot of little dots that represent individual scientific observations conducted by the telescope. It's made over 1 million observations in total. About half of those are flagged in the database as scientific observations. So those are the ones I've put on the screen for you. In fact, I'll do something you should never try at home. I'm going to get rid of the Earth so you can see a few more of them. Now, you might notice some different colors as well as some different patterns on the screen there. A couple of patterns jump out at me. First, we've got some blue dots, and most of those are in a band, kind of stretching across the screen from side to side here. Now, if I add something like the orbits of the other planets in our solar system, you might notice that those are all on the same part of the screen. So it's a big hint. Those blue objects are other members of our solar system that Hubble has observed. So the other planets, their moons, a lot of dwarf planets, asteroids, comets, things like that. Let's see some of the other dots. We've got yellow ones. Those are observations of other stars. There are red dots, which are observations of other galaxies. You might also see some white dots. That's really where these multicolored dots are overlapping. There are pink dots there as well. It's kind of a catch-all for everything that wasn't well categorized. Sometimes they just observe two things with two instruments at the same time, and so the secondary target just ends up pink in my visualization here. Then there are some green dots. Those are a little rarer, a little harder to pick out. Those green ones are clouds of gas, whether it's material between the stars, called the interstellar medium, or nebulas, like those created when giant stars die, or in regions where new stars are being born. And it's those kinds of big clouds of gas that scientists working with Hubble decided to use in a new image to celebrate the telescope's birthday. Every year, Hubble scientists compose a new image to celebrate the anniversary of the telescope's launch. And this is the image selected for this 30th anniversary. We actually see two separate nebulas here. The one that dominates most of the screen, the big red one, is called NGC 2014. And this is a stellar nursery, a place where brand new stars are being born. A lot of those new stars are actually in the bottom part of your screen. They're bright and blue. And the energy from these new hot stars energizes the gas, and it glows in certain wavelengths, which the telescope is observing here. And it's been colorized by the scientists so that we can pick out what's present. The reds in this image are mostly because of hydrogen and nitrogen. Where you see blue, that's mostly oxygen. Speaking of blue, there's also a big blue nebula in the top right corner of your screen. Made a little bit more of it on there for you. Now that's a separate nebula. Its name is NGC 2020. It's no coincidence that they included NGC 2020 in the Hubble anniversary image in this year, 2020. But what we're seeing here is something a little bit different. And this is still a relatively young star. It's a special kind of star called a Wolf-Rayet star. Now, these stars are incredibly hot, and what this one has done is actually, with its highly energetic stellar winds, has driven some of the material off of its outer layers, and it's created this bubble of gas around itself, and then the energy from the star is again energizing this gas, making it glow, and the blue is again that telltale sign of oxygen. So pretty interesting science just at first glance at this image, and Hubble is still doing good science too. It's not just a telescope out there taking pretty pictures. Here are a couple of interesting bits of science it has done just in the last few weeks. So if we return to a wider view of the sky, you'll see those familiar multicolored dots again. And I'm going to add to this view some blue circles. And these circles represent all of the exoplanets, those planets around other stars that we've discovered. And you can see some places where the Hubble observations and the exoplanet circles overlap. One I want to highlight is a star named FOMO Hot. Now, FOMO Hot is thought to have one planet in orbit around it, at least by most people. It was first spotted in images taken by Hubble dating all the way back to 2004. It was announced in 2008. But as Hubble continued to observe this planet, astronomers noticed some strange things. The planet was getting dimmer in the Hubble images and also appeared to be growing larger. It's not really planet-like behavior. So new analysis of all of the images taken by Hubble over the years has led to astronomers suggesting a new idea, or perhaps strengthening an older theory. What Hubble may have observed instead of a planet may have been a collision between two smaller objects. Think of maybe a couple of the asteroids in our solar system. If they were to collide, there'd be a cloud of debris. At first, the cloud is pretty small. And so in the Hubble image, it would look smaller, it'd be denser, so it would look brighter too. Then as the debris spreads out, in the Hubble imagery, it would get larger and also dimmer. So perhaps instead of finding a planet, Hubble just observed an even rarer event, a collision between two objects in this distant planetary system. And it's also still giving us new insights into our own solar system. It studies all kinds of objects. I mentioned planets, moons, asteroids, comets before. And it's made some news with comets recently. As recently as a few days ago, it's been observing a comet named Borisov. And Borisov is pretty interesting. It's the first confirmed interstellar comet to be found in our solar system. And recent Hubble images have shown that Borisov is breaking apart. That's not terribly unusual, but we'll come back to that. Other observations from Hubble, as well as radio telescopes here on Earth, have helped astronomers find that Borisov has a lot more carbon monoxide gas in it than any comets we've observed in our solar system. That's pretty interesting because carbon monoxide is very volatile. It's easily driven away by energy from stars. So if it had formed in our solar system, it wouldn't have that much carbon monoxide in it. That's leading astronomers to think that Borisov may have formed around a smaller, cooler star. Maybe like one of those red dwarf stars we saw in the Kepler 1649 system. Now, this isn't even the only telescope that Hubble has observed recently. It's not the only comet that Hubble has seen breaking apart this month. It's also been observing one that was discovered late last year. It's called Atlas, or if you want to get technical, C2019Y4. Now, when this one was discovered, there was some excitement because it was thought that as it approached the sun in May, it would actually get bright enough for us to see it in the nighttime sky without using a telescope or binoculars or any special equipment like that. But telescopes here on Earth, as well as the Hubble Space Telescope, have witnessed this comet begin to break apart. So we've had Borisov and Atlas both breaking apart this month, and that lends more credence to the idea that it's a pretty common thing for comets to do. But Hubble's unique observations might help us better understand exactly why it happens. Is it simply the warmth of the sun that breaks down the ice in the comet nucleus? Or is it maybe something else, like the jets of gas that are released, maybe spinning up the comet so it spins so fast that it tears itself apart? we haven't really figured that out yet. So observations like this can still go a long way to furthering our knowledge of the solar system around us. Well, since we won't be seeing a comet like Atlas in the nighttime sky, I thought I'd take just a few minutes to show you a few things that you can see from home, even if you don't have a fancy telescope like Hubble. So I'm going to make a couple of quick adjustments here. I'm going to clear off this view. I'm going to take you back home. We're also going to head into the future just a little bit. So I'm going to adjust your view, make it a little bit easier to see the stars, and add some information to the screen for you. So I've now got the planetarium software set up for the situation as we'll see it from Earth a little later on tonight. This is a couple of hours after the sun sets, should be around 10 p.m. local time for you. Now, this view is not really anything compared to what you'd see out in the real world. And this is probably where being on a small monitor like this, rather than the dome at the museum, really hurts the presentation more than anything else. So I won't spend too much time here, but we do have an astronomy bingo game that is going out this week. And so just in case you're playing along at home, I wanted to give you a couple of hints, try and be helpful. So let's see, what are some things you can see in the nighttime sky these days? Well, in the evening sky, the highlights are probably going to be over in the west. Now, just by default, I have set up the sky with us facing south. So we're going to make one more adjustment, turn to the right here just a little bit. Now, I've really exaggerated the stars to make them a little bit easier to see on your screen. But outside, the first thing to catch your eye in the nighttime sky these days should be the moon. If you don't see it on your screen right now, that is totally understandable. So I'm going to do a couple of things to help you out. First, I'll put a big circle around it. Okay, kind of a small circle. I'll put a label on it, and I'll make it just a little bit larger for you temporarily. So that's the location of the moon in the sky tonight, almost due west and fairly high in the sky. It'll be a first quarter moon tomorrow, so it's a fairly large crescent moon tonight. If you're outside facing west tonight, the next thing that should catch your eye sort of blends in on your screen right now, but you'll have to take my word for it. There'll be one other object much lower in the western sky. It'll be much brighter. It'll outshine all of the stars around it. And when something is that bright in the sky, it's usually a hint that it is not one of the stars. It's one of the other planets in our solar system. And the really bright one in the western sky in the early evening right now is the planet Venus. And again, it really blends in on your screen right now, but we can take a closer look here during the show. So we'll pretend that everyone is using a virtual telescope. We'll point it in that direction, and we're just going to zoom in a little bit. Now, just to your unaided eye in the nighttime sky, Venus will just be a really bright point of light. But through a little telescope or good binoculars, you can see that, it is another planet. It's another world out there. And because Venus is a little bit closer to the sun than we are, and because it's about to move between the Earth and the sun, it goes through phases, kind of like the moon does, and it's currently in a crescent phase as well. So as we get zoomed in here, that one bright dot will be replaced with an accurate representation of how Venus appears in telescopes these days. It's a little bit skinnier crescent than the moon is right now, but there you go, a telescopic view of Venus as it appears right now. So the Venus and the moon in the western sky this evening. Pretty easy to spot. All the other bright objects in that part of the sky are going to be stars. A lot of them have been in the evening sky all through the winter, and so maybe a little more familiar to you, but they're getting a little bit lower in the sky in the evening these days, so they're a little harder to catch. I'll identify a couple of the bright ones for you. Let's see, let's start right next to the moon. Just to the right of the moon, again, relatively high in the sky, basically due west, are a couple of fairly bright stars that are basically the same brightness but different colors. The bluish one is named Castor, and the more red one, a little bit closer to the moon, that one is named Pollux. Those two stars are the heads of the Gemini twins. Gemini, a pretty famous constellation, but I got to be honest with you, I have a little bit of trouble imagining a lot of the connect the dots pictures that the constellations are supposed to represent. But Gemini isn't too bad. I'll have the computer take care of some of the work for us. I'm going to connect a lot of the major stars in Gemini, and it's supposed to be twins, so two people. And when the red lines appear on your screen, even without too much work, you can probably agree with me that it does kind of look like two people. That's not always true for the constellations that are easy to find in the sky. Let's look just below the moon. So let's see, that's Castor and Pollux. The moon right there will drop straight down. Another fairly bright star in that part of the sky is named Procyon. Procyon is the brightest star in the constellation Canis Minor. If your Latin is any good, you know that Canis Minor just means little dog. And if the computer connects the major dots in Canis Minor, you don't have a whole lot to work with. But this is supposed to be a little dog, something perhaps kind of like this. So you can see that some of the constellations take just a little bit of imagination. If you really want to see just how much imagination some of these can take, let me put Gemini back up there. We'll clear Canis Minor and Procyon off. If we kind of stretch out the arms of the Gemini twins to the right, they're going to point more or less to another bright star. This one is named Kepler. Now, Kepler is the brightest star in a constellation named Auriga. And if I connect the dots in Auriga, you're really going to be hard-pressed to imagine what this is. But I don't want to give away all the answers, so I'll just leave this one as an exercise for you after the show. Before we leave the nighttime sky entirely, I do want to give you a few other highlights. We're going to have to make some big adjustments for these. We're going to leave the evening sky behind. I'm going to get you pointed a little more to the south again. So things are going to start spinning on the screen. I'm also going to adjust time. I'm going to move us to the early morning sky. So we'll also fade out for just a second and then bring the stars back. Now, if you happen to wake up really early tomorrow morning, this is something like 4 in the morning, the sky will be pretty different. That's because the Earth is always rotating, and so things appear to move across the sky. But in the early morning skies, the highlights for me really going to be 3 bright planets and 3 bright stars. To find them all, we need to turn to the east just a little bit. We'll start low in the southeastern sky, and we'll find the 3 brightest dots in this region. Again, on your screen right now, they probably blend in with the stars just a little bit. But outside, under the nighttime sky, you should see 3 objects that are noticeably brighter than the stars around them. To really help you out, we'll do the same thing as before. I'll add some circles and some labels to the screen for you. So as these appear, you'll see that we've got 3 planets. They are Jupiter, Saturn, and Mars. Now, something jumps out at me here right away. These 3 planets are all lined up across our sky. And, well, you may remember that the same thing happened for the Hubble observations. And that's just, again, because all of the big planets in our solar system move across the same part of our sky. They're all lined up in their orbits around the sun. So they all stay lined up for us all the time. So that can really help you identify those planets in the sky. A special path they follow is called the ecliptic. And you can see there's a blue line on your screen now, and it helps remind you that those planets stay pretty close to it. But really, my absolute favorite part of the entire nighttime sky, also visible early tomorrow morning. If you really want to see it, I recommend waiting until a little bit later on in the summer. then it will be conveniently placed in the evening sky, and that's when I like to go outside and do a little stargazing. But I can show you what it looks like on the screen right now. We just need to look a little bit higher in the sky. Almost directly overhead at 4 in the morning tomorrow, there'll be 3 bright stars. A little bit more obvious than on the screen for you right now. So I'll just circle them. These 3 bright stars are almost directly overhead, Vega. Then a little bit lower, not too far from those planets, a star named Altair. And then a little farther back, a star named Deneb. Each one of these stars is part of its own constellation. But if you ask me, 3 bright stars, the easiest connect the dots picture to draw here is just one giant triangle. This triangle is known as the summer triangle. Pretty easy to remember. And my favorite part of the entire nighttime sky is right along that skinny edge of the triangle, the northern edge of the triangle. That's that same patch of sky you saw a few minutes ago. That's where Kepler was looking for exoplanets for the first half of its mission. That's where it has found over 2,000 planets and counting. If I add those blue circles back to the screen for all of the planets we found outside of our solar system, you see how a lot of them are concentrated right along that edge of the summer triangle. Now, you're not going to be able to see most of the stars that Kepler studied with your own eyes. You're not going to be able to see any of those planets, but I still think it's really interesting to know that you can look at one little patch of the sky and you're looking in the same direction as most of the planets we found outside of our solar system. Just kind of a fascinating big picture moment that I enjoy. So those are some of the highlights in the nighttime sky these days, but there are also a few more stories that you're likely to see if you read any space news at all in the coming months. And I'm going to give you a heads up on a couple of those because well, they're really going to be dominating the headlines, and I want you to be familiar with them. One you may already be seeing these days. It was an event that just happened this morning. If we jump up off the surface of the Earth, I will be able to highlight a little object that visited our neighborhood about 6 a.m. today. We've got the Earth there on the screen for you. I'll start backing up in just a couple of seconds. You might be able to pick out the moon off in the distance as I start moving. Then I'm going to add to the screen our latest visitor. It's a little asteroid. It's called 1998 OR2. Now, already over the last few days, there have been plenty of stories about it online because, well, it got pretty close. In astronomical terms. It flew within about 4 million miles of the Earth earlier this morning. It's about 6.3 million kilometers, or if you prefer, a little more than 16 times the distance between the Earth and the Moon. So it wasn't close enough to pose any danger to our planet. Those numbers are pretty big, so the best way I can put the danger in perspective posed by this asteroid is for everyone to imagine parking a brand new car in a grocery store parking lot, and then imagine a shopping cart rolling past at a distance of about 4 million miles. So, yeah, not a whole lot of danger, but this is the closest approach by a large asteroid for most of a decade. These real observations from the Arecibo Observatory have helped confirm that 1998 OR2 is about 2 kilometers wide, or about 1.25 miles. So big enough to do some pretty serious damage if it were to hit the Earth. For that reason, we want to understand as much as possible about the asteroids that approach the Earth, whether they're going to hit us or not, because there's always a chance that someday we will find one on a collision course. So for that reason, despite the impact of the COVID-19 pandemic all around the world, some critical space science, like asteroid monitoring, is continuing. And that's not the only kind of space science that continues. We have a lot of other spacecraft spread across the solar system that are studying other worlds for us and helping us expand our understanding of the universe around us. I want to highlight a couple of those, especially ones that, again, will be in the news a bit over the next few months. So I'm going to add all of the active spacecraft that we have beyond Earth orbit to your screen. One will briefly fill the whole screen, but I'll shrink it down as fast as possible so you can actually read some of the labels. In close to the Earth, we have a handful of spacecraft that are exploring the moon, and then there are others that are mostly studying the sun. They're stationed at gravitational balance points between the Earth and the sun. If we zoom out a little bit, the first one to catch your eye will probably be one of the best names in all of planetary science, a spacecraft named Bepi Colombo. That one is on its way to Mercury, but it just flew by the Earth earlier this month to help refine its trajectory towards Mercury. A little farther away, the spacecraft I really want to highlight include, off in the distance, an interesting looking acronym, OSIRISRex. Kind of sounds like a dinosaur. And then I'll bring the location of Mars into view for you. You may be able to see that there's already a small fleet of spacecraft exploring Mars, and more should be joining that list in the not too distant future. So here's some big stories to keep an eye on in the coming months. First, let's revisit that OSIRIS-REx spacecraft. It was in the news a little bit a couple of weeks ago and will be again later this summer for its exploration of the asteroid Bennu. OSIRIS-REx launched from Earth back in 2016. It's been studying Bennu since 2018, mapping its surface in detail. So you're seeing real imagery from the spacecraft. In fact, Bennu is now the object in the solar system that has the highest resolution global map of any world, Earth included. Now, this map is needed because OSIRIS-REx's ultimate goal is to descend all the way to the surface of the asteroid, collect a sample, and return it to the Earth. To help it with this goal, it did a rehearsal earlier in April. So you're seeing real imagery collected by the spacecraft. So you see the asteroid in the background there, and you see the end of its sample collection arm in the little video as well. Now, the device at the end of the arm is not that different from an air filter. They're just going to touch the surface of the asteroid, shoot a little bit of nitrogen gas that'll churn up some of the loose material on the asteroid. It'll get caught in that filter, and then they'll store it away and bring it back to Earth. They are targeting late August for this sample collection. There's probably going to be at least one more rehearsal in the meantime. So this will be NASA's first sample collection from an asteroid like this, so I'm sure it will get plenty of attention when it happens. So maybe circle August 25th on your calendar for now. Before that, you're going to see a lot of news about spacecraft heading to Mars. Every couple of years, Earth and Mars are well aligned in their orbits for spacecraft to leave our planet and explore Mars. Earlier this year, as many as 4 spacecraft were scheduled to launch. But back in March, the European and Russian space agencies agreed to delay the launch of the ExoMars lander and Rosalind Franklin rover until the next launch window in 2022. A couple of things contributed to that. They were already having some trouble with the parachute that was needed to get the rover safely to the surface of the planet. And then the impacts of the COVID-19 pandemic have understandably made it difficult for teams from multiple countries to get together and conduct the tests that were needed to make sure the lander could get to the surface safely. So 3 spacecraft remain in the 2020 Mars fleet. 2 spacecraft on the right, I can't tell you a whole lot of details about, not a lot of public news available, but here's what we do know. In the top right, an orbiter built by the United Arab Emirates. It'll be their first interplanetary spacecraft. Looks like the spacecraft has shipped to its launch site in Japan, so they should be on track for their late July launch. Similarly, the lander you see in the bottom right, that would be China's first mission to Mars. It's what they hope is the first in a series of missions called the Tianwen series. Now, Tianwen-1 would have the lander and rover that you see on the screen, as well as an orbiter. So it's a pretty ambitious mission. But the Chinese space program has brought unique views to lunar exploration. So it'll be pretty interesting if they can ramp up their Mars program as well. And I can give you plenty of details about the rover you see in the top right. This is NASA's next mission to Mars. It is the Perseverance rover. The name was given to the rover just a couple of months ago, suggested by a Virginia student as part of a naming contest held by NASA. Perseverance has shipped to its launch site at the Kennedy Space Center, and it's undergoing final testing and assembly. Now, one thing that has been in the news just this morning is that its payload has gotten a name too. It's taking a little helicopter to Mars. You can see it there attached to the surface of the rover, along with the rover's newly attached wheels. This helicopter has just been given a name as well. It'll be called Ingenuity, and Ingenuity will hitch a ride to Mars with Perseverance. After a couple months of checkouts by the rover, it'll drop off Ingenuity, and then Ingenuity will be able to fly on Mars. It'll be the first spacecraft, or I guess the first aircraft, to attempt independent flight on another planet. So it'll be a pretty historic part of the mission. They're hoping that Ingenuity's flight mission could extend as long as 30 days. Not continuous flight, but they're hoping it'll be operational for at least that long. Together, Ingenuity and Perseverance will explore a pretty interesting region of Mars. They're targeting a crater called Jezero. And this site has been selected because it looks like a favorable place to better understand the history that liquid water has played in the history of Mars, as well as look for evidence of past habitability and perhaps ancient life on Mars. We're pretty sure there used to be a lot of liquid water on the surface of Mars, but we don't really understand how long it was there and why and when it went away. So that's all part of Perseverance's mission. You should be seeing an aerial view of Jezero crater now. The blue ellipse is the landing target for the rover. It's fairly large, but that's okay. The rover is on wheels, so it'll be able to explore, much like the rovers that went before it. Their main interest is this feature here. It's what we call an alluvial fan. It's likely a deposit laid down by material that was carried by running water. Off the top of the screen, you might even be able to pick out the path that a river may have followed a long time ago, carrying this material into the crater, dropping it off, building a feature similar to a river delta. So if water had persisted here for a long time, perhaps life took hold here, and perhaps if water was present long enough, some of the signs of that ancient life has been preserved well enough for Perseverance to find it and analyze it. The rover is also supposed to collect some samples that will be stored and perhaps picked up by a future mission and returned to Earth. So a lot to watch with the Perseverance mission. Again, its launch scheduled for late July. Then it will arrive in February of 2021 and begin its exploration of Mars. Well, ultimately, we'd like to send humans to Mars as well, but you can't do that without leaving the Earth. Well, seems pretty obvious, but in about a month, we may see something here on Earth that we haven't seen in almost a decade. Astronauts have still been flying to the International Space Station regularly over the last decade. In fact, we're about to mark 20 years of continuous habitation of the International Space Station. But since the space station, the space shuttle was retired in 2011, no NASA astronauts have launched from American soil. They've all ridden on Soyuz rockets launched from Ukraine. Now, in the meantime, NASA has been working with multiple contractors to design new spacecraft that will be able to launch from Kennedy Space Center and carry NASA astronauts into space. And it looks like SpaceX is now scheduled to carry their first astronaut crew into space. Launch is currently targeted for May 27th from Launch Pad 39A. It's the same one where all of the astronauts that walked on the moon left the Earth, is where a lot of the space shuttles launched as well. This crew will be using SpaceX's Falcon 9 rocket and their Crew Dragon spacecraft to journey to the International Space Station. The crew is composed of 2 astronauts, Bob Behnken and Doug Hurley. So they'll launch, they'll dock with the space station, and then they'll join the long-term crew on the ISS. Exactly how long they remain on the space station hasn't been determined yet. That will vary based on how the spacecraft performs. It's already undergone one uncrewed spacecraft, but this will be the first chance to check it out with astronauts on board. So a lot to be determined, and there are still some tests that have to happen before the launch does take place. So that date may change a little bit, but in the very near future, astronauts will be returning to Earth orbit after launching from Kennedy Space Center. That'll be a pretty historic moment in space exploration as well. All right, so I know that was kind of a whirlwind tour of a lot of topics, but that's what's been going on in space for the last few weeks, and this is some of the stuff we can look forward to in the coming weeks and months. With that, we can open it up to any questions or any topics that we need to revisit from earlier in the show. So, so Tim, if we've got anything, let me know.
Yeah. Oh, yeah. We have a ton of questions. I'm wondering if I shouldn't go backwards or what. I think I'll start with the most recent one because it refers to what you were just talking about. We have 2 questions about the going to the International Space Station in particular. One would be what makes the launch locations optimal, and the other one was asking if we're able to show those launches here at the museum.
Okay, so what makes the launch locations optimal? Let's do that first. And since we're hanging out here at Earth, we should be able to do that. So to pick a good launch location on Earth, one thing you want to take in mind is that the Earth is rotating. And so if you can take advantage of that rotation to help you get into orbit, it's going to be a good thing. Now, that means that thanks to some physics that I probably won't explain today, you want to have your launch site as close to the equator as possible. So if I can remember the command to type, should be able to add Earth's equator to our view here. So there you go, United States, not especially close to the equator, but you should be able to see pretty quickly that Florida is about as close as you can get to the equator in the U.S. So that's why Kennedy Space Center is located in Florida. Now, the Earth is also rotating such that in the view that you're seeing now, the surface of the Earth would move from left to right. So, hey, should be able to set time and motion here as well. So if you were to launch from Florida, you could, I guess stars are moving in the background instead of the Earth for you. But if you launch from Florida and you launch out over the Atlantic Ocean, then you're launching in the same direction that Earth rotates. So you actually get a little bit of speed boost from the planet itself. And that helps you get up to the 17,000 miles per hour that you have to be traveling to get safely into orbit. So that's why we launched from Florida primarily. Let's see, the other question. I'm sorry, remind me of the second question.
Oh, are we able to show the launches at
right.
the museum?
Certainly, we could show the launches. In May. Certainly don't know if we'll be able to show them at the museum physically, but they also stream online. I'm sure NASA will be streaming it on NASA TV, and we can certainly make sure that you have links to get to the right place for that.
So I want to get as many questions in as possible. We had one on Jupiter. They heard that it intercepts a lot of asteroids that could possibly hit the Earth. Is that true? And then at the same time, when you're talking about Jupiter, I had a snake named Juniper. I say it a lot. They wanted to know, I guess the same thing as the Perseverance launch. Are you able to see that from our local area?
Okay, so the Perseverance launch, that'd be another thing that would probably just want to stream through NASA TV or some other resource. We can certainly make sure that you point to that at the right time. I believe it is around July 17th that is scheduled, but there's a little bit of wiggle room there. And Jupiter, yeah, it does do a little bit to help protect the Earth from things like asteroids and comets. Let's see. Let's get a nice wide view of the solar system here. And let me add a couple of things to the screen for you. Most of the asteroids in our solar system are kind of trapped in the main asteroid belt. It's between the orbits of Mars and Jupiter. So if you zoom out here a bit, you see a lot of little dots in between the orbits of Mars and Jupiter. Then Jupiter would be the fifth planet from the sun there. Now, that's pretty big, so its gravity is pretty strong, and so it has done a lot to help keep asteroids organized, especially in the asteroid belt. But then again, the reason that we have so many near-Earth asteroids is because of the way Jupiter affects the asteroids in the asteroid belt. It's actually the influence of Jupiter that creates the push that asteroids need to get into the inner solar system. So it probably hurts as much as it helps, to be honest with you.
I have a question on what's the best way to see the Milky Way. Some folks have mentioned that it's really hard to find, so we'd like to know some tips for that.
Okay, yeah, it is definitely almost impossible to find from a large city. Best thing you can do is get away from as many lights as possible. The Milky Way, it stretches all the way across the sky, but it is easily drowned out by light pollution, by city lights around you. So that's the first best advice I can give you. As far as when and where to look, right now, the best time to look would be early in the morning. Let me get us reset for that. So if I take you back to that early morning view I had before, so around 4 in the morning. The brightest part of the Milky Way is actually the center of the galaxy, and that's always low in the southern skies for us, at least in Richmond and from similar latitudes, similar parts of the US and northern hemisphere. So this is, again, facing due south about 4 in the morning. This is tomorrow morning. And you might just be able to make out the brightest part of the Milky Way on your screen. There's this kind of cloud just above the letter S. But of course, I can always cheat here. So we will make that just a little bit brighter for you in just a moment. Yeah, well, we are not at the center of the Milky Way. And so if we look towards the center of the galaxy, we see many, many more stars off in the distance. And so that part of it is much brighter, easier to see. It'll be in the sky this evening too, but we're looking in the opposite direction. Too faint to really see, even if you get away from most of the city lights. So look low in the southern sky, away from city lights in the early morning right now. Later in the summer, it'll be earlier in the evening.
All right. Okay, there's a lot more questions that we may not be able to get to today, but I do want to get to one more. We've got someone wants to know just a little bit about what is a pulsar.
Okay, a pulsar. So pulsars are the leftovers from giant stars. When they reach the ends of their lives, they explode as supernovas, and sometimes what is left behind is a rapidly spinning neutron star. Now, you can find the location of one in the sky. Kind of tough these days, but one of the most famous would probably be the one at the center of the Crab Nebula. Well, let's just see if we've got something queued up here that put something interesting on the screen for you. It's not well placed in the nighttime sky these days. But these rotating stars, they send these beams of high energy radiation out across space. And when they were first detected with radio telescopes, this rapidly repeating signal was, initially flagged as possibly an alien signal, but it was quickly discovered that this was a natural thing, and so we've now found that pulsars are all over the place. Got a really fun view of it, but on the fly here, gotta remember where it's at. So we've now found thousands of these leftovers from supernova explosions all across the sky, and yeah, they're pretty interesting objects. They've actually been used to map our location across the galaxy with the Voyager record that we sent out away from the solar system. It carried on it a map that showed the location of the Earth relative to about a dozen pulsars in the galaxy. So here we go. Should get some pulsars on the screen for you in just a second. So these objects, pretty interesting. This is now showing the pulsars as they appear in our nighttime sky. So they don't look like anything to you. You basically need radio telescopes to see them, but thousands of them out there.
Kind of like, I want that as a screensaver. So we didn't get to all the questions, but we've been doing a series of Ask an Astronomer, so I'll make sure I've got them saved. Maybe we could address them during one of those. And I want to thank everybody for coming today. I hope you guys enjoyed it. We will have this up on our YouTube channel shortly. And next week at the same time, if you'd like to join us, our speaker is Dr. Catherine Franson. She's an associate professor of psychology and neurobiology at Longwood University, and she's going to be talking about neuroscience and nature. So thank you, everybody. Thank you to Justin, and please stay safe and healthy, and see you next time.